So in this video, I'm going to show you all how to create a program that classifies images. Now, currently I'm on Google's website called colab.research.google.com because it makes it really easy to start programming in Python. And that means that you don't have to install Python onto your computer. You can just go to this website and then log in using your Google account and get started writing your Python code. So to get started writing this code, you're going to want to click on File and then click on New Notebook, and a new tab will open up for you, and then a new cell will open up for you. Now in this cell, I'm going to put in some comments. So I'm going to put a description about the program, and I'll make that a capital D. Okay, so this program will classify images, or this program classifies images. All right, now I'm going to create a new cell by clicking this code button in the top left. And in this cell, I'm going to import the libraries that I plan on using throughout this program. So I want to import TensorFlow as TF, and then from TensorFlow I want to import Keras, and from keras.models I'm going to import sequential, and from keras.layers I'm going to import dense, flatten, conv 2D, max pooling 2D, and dropout. Okay, now from TensorFlow.keras I'm going to import layers, and from keras.utils I'm going to import to_categorical, and I want to import numpy as np, and I'm going to import matplotlib.pyplot as plt. And then I'm going to give this plot a style, so I'm going to type plt.style.use, and I'm going to use 538. Okay, so now I'm going to run this cell by clicking this button here to the left, and hopefully there are no errors. All right, so there are no errors. Everything seems to be working fine. So let's go ahead and create a new cell, and I'm going to scroll up. And now in this cell, I want to load the data. So from keras.datasets, I'm going to import cipher10, and I'm going to create a or two tuples or tuples. You can say it both ways, I believe. So I'm going to create one tuple is x_train and y_train. So this will contain the training data set. And I will create another tuple, x_test and y_test. And so that tuple contains the test data set. All right, and I'm going to set them both equal to cipher10 dot data, dot load_data. And then I'm going to run this cell, and the data is being downloaded. Okay, so it's done. I'm going to create a new cell. I'm going to scroll on up here, and I want to take a look at the variable data types. So here I'm going to look at the data types of the variables. So in order to do that, I'm going to print type, and then I'm going to input the variable name. So x_train will be one variable. And to make this a little quicker, I'm going to just highlight it and copy it. And then I'm going to paste this about 3 more times. And I'm just going to change the variable name inside of these parameters here. So instead of x_train here, I'm going to put y_train. Instead of x_train here, I'm going to put x_test. And then last but not least, I'm going to put y_test here. And then I'm going to run this cell. And now I can see that all 4 of these variables are NumPy arrays. Okay, so let's get the shape of these arrays. So I'm going to create a new cell, And again, I want to get the shape of the arrays. All right, so in order to do this, I'm going to create a print statement. And I'm going to put x underscore train shape and then colon. And then we're going to put a comma and I'm going to put x underscore train dot shape. Okay, so this will give me the shape of the x train variable. I'm going to copy this and paste it about 3 more times and just change the variable name. So instead of x underscore train here, this will be y underscore train. And instead of instead of x underscore train dot shape, this will be y underscore train dot shape. And I'm basically going to do the same thing like I did above. So here will be x underscore test. And then same for here. I'm going to change this to x underscore test. And then this will be y underscore test and y underscore test here. Okay, now let's run this cell. Okay, and I want to understand what's going on here, right? So what we see for the x train shape is that we get a 4-dimensional array. And what this is telling us is that we have 50,000 rows of data, and those are rows that contain 32 by 32 images with depth 3 for red, green, and blue. All right, so I think that's pretty understandable. The y train variable contains 50,000 rows of data and 1 column, and it's 2-dimensional. Okay, the x underscore test variable contains 10,000 rows of data, and those are 10,000 rows of 32 by 32 images with depth equal to 3. And the y underscore test variable contains 10,000 rows and 1 column. All right, so that looks good. Let's create a new cell. And now I want to take a look at the first image. And I want to take a look at it as an array. So I'm going to create a variable called index and set it equal to 0. And I'm going to take a look at the training data set. So I'm going to type x underscore train at index. In this case, index 0. So let's run this. Okay. And I can see the image here as an array. So there's really no picture, right? So let's take a look at it as a picture, the image as a picture. So I want to show the image as a picture. And I'm going to create a variable called img and set it equal to plt.imshow. And let's input x underscore train at index or position index. And let's run this. Okay, I'm going to scroll this on up. And now we can see this 32 by 32 image of what looks to be a frog. All right, so let's get the label of this image. So I'm going to create another cell. And here I'm going to get the image label. So just print the image label is colon. And then I will put y underscore train at index. Okay. So let's run this. And we can see that the image label is 6. Now you may have been expecting the image label to be something like frog. Well, in this data set, every number corresponds with a classification. So the number 6 corresponds with a frog. So let's actually do that mapping ourselves to get the image classification. So I'm going to create a new cell. And I want to get the image classification. So I'm going to create a variable called classification and set it equal to I'm going to put airplane here, and I'm going to put airplane in the index 0 or position 0 because the number 0 corresponds to airplane or maps to airplane. All right, and then automobile will be in position 1 because automobile maps to 1, and bird will be in position 2 because 2 maps to bird. All right, I think you understand the pattern, so I'm just going to continue here. Get cat, get deer, the dog will be the next classification, and then the frog at position 6, and then horse, and ship, and then truck. Okay. All right, so that looks good. Now I want to print the image class. So here I'm just going to put a print statement, and I'm going to print the image class is, and then colon, and then I'm going to put classification at position y_train at position index, and let's run this. Okay, so I made a mistake here. Let's see where classification y_train at position index. All right, so let's see what we get. Okay, so the problem here is that I need to get just the value, which is at position 0. So let's run this again, and now we get the image class is frog. Okay, so that looks good. So now we can see that the image here is a frog, or it's classified as a frog. Okay, so let's go back up and let's just play around with this index. I'm going to put in the number 10 for the index. So let's run this and see what that image looks like as an array. So we see that the array values have changed, and let's scroll down. Let's see what it looks like as a picture. Okay, and it's actually very hard to tell what this is, so I'm kind of curious myself. Let's run this and get the label. So the label is 4, and then let's get the classification. And so this tells us that the image is a deer, and if I go back up, I can actually kind of see the deer in this image. Looks like it's surrounded by some plant life. Okay, so hopefully all of that was understandable. And now let's prepare the data for the neural network. So I'm going to create a new cell. And here I want to convert the labels into a set of 10 numbers to input into the neural network. So I'm going to create some variables here. So I'm going to create y_train _1 hot, or 1_ hot. And we'll set this equal to 2_ categorical. And we're going to input y_train. And then we're going to create y_test 1 hot and set it equal to 2_ categorical and input y_test. So let me run this. All right, this is actually taking some time. Okay, so now it's done. Let's create a new cell and let's print the new labels. So I'm just going to type print, and then I'm going to put y_train _1 hot, and let's run this. Okay, and now we can see the new labels, the converted labels. So what are we looking at here? Basically what you're going to see is a set of 10 numbers, and all of the columns will contain the value 0 except for one column. All right, one column will contain the value 1, and that will be corresponding to that label. So let me show you what I mean. We'll create a new cell here, and let's print the new label of the current image or picture above. So I'm just going to print the one hot label is y underscore train underscore one underscore hot at position index. So let's run this. Okay, so this set of 10 numbers corresponds to that label 4. And we know this, and we can check this by looking to identify where that 1 value is. So we can see it is in position 0, 1, 2, 3, 4. Okay, so that's basically what's happening here. So I think that's understandable. Now that we have that conversion, let's normalize the pixels to be values between 0 and 1. So I'll put that in some comments here. Normalize the pixels to be values between 0 and 1. All right, so I'm going to set x underscore train. I'm going to set it equal to x underscore train divided by 255, and then I'm going to set x underscore test equal to x underscore test divided by 255 as well. And let's run this. Okay, so now all the pixel values should be between the values 0 and 1. So let's actually take a look at it. Let's take a look at x underscore train at position index. I'm just going to run this. And now what you see are that these values here are values between 0 and 1. Okay, so that's exactly what we did there. I'm going to exit that. Let's create a new cell. And now let's actually create the model's architecture. So here I'm going to create the model's architecture. All right, so I'm going to create a variable called model, and I'm going to set it equal to sequential. All right, now I'm going to add the first layer, and this first layer will be a convolution layer to extract features from the input image, and then it will create 32 5x5 ReLU convoluted features or feature maps. So that sounds much more complicated than what it actually is. Let's just go ahead and implement this. So just type model.add, and inside here we're going to add conv2d. Okay, and inside of conv2d we're going to add 32, and then we're going to add 5, 5 for the tuple or tuple, and then we need to give it an activation function. So it will be the ReLU activation function. And since this is the first layer, we have to give it a input shape. So the input shape will be 32 by 32 by 3. Okay, so I think that's good. Let's go ahead and create another layer. So in this layer, I'm going to add a pooling layer. All right, so just type model.add, and then I'm going to add max pooling 2D, and then I'm going to give it a pool size. So the pool size will be 2, 2, or 2 by 2 pixel filter. All right, and this right here is basically creating a pooling layer with a 2 by 2 pixel filter to get the max element from the feature maps. All right, so let's keep going down. I'm going to bring this up a little bit. and I want to add another layer. I'm going to actually add a second convolution layer. So I'm just going to copy this here, and I'm going to paste this here, and I put some comments. Add another convolution layer. Okay, and this is not the first layer, so we need to get rid of this input shape, and that should do it. And then I'll add another pooling layer, so I'm just going to copy this here and paste this here, and I'm going to put add another pooling layer here. Okay, so I think that's good. Now let's add a flattening layer. So just type model dot add flatten, and this should reduce the dimensionality to a linear array. All right, so that should work. All right, so now we can take all of this data and input it into some neurons. So let's create a layer with 500 neurons. All right, so here we're going to add a layer with, I said 500, but you know what? I'm going to make it 1,000. All right, so just type model.add, and then we're going to put in dense. And I'm going to put in 1,000. And then I'm going to give it an activation function. And I hope I said function here as well and here as well. But anyways, activation function, it will be ReLU. All right, so I think that looks good. Let's add a dropout layer. And this will be a dropout layer with a 50% dropout rate. So just type model.add and then dropout and then put in 0.5. Okay, so that looks good. I'm going to just copy these two layers, and I'm going to basically create them again, but this time instead of 1,000 neurons, I'm going to put in 500. Okay, and then I will keep that dropout rate at 50%. Okay, and I will add one more, maybe, yeah, I'll add one more layer of neurons. This time it'll be 250 neurons. Okay, and I add one more layer of neurons. So I'm just copying and pasting here, which I hope will speed this up, but it may actually slow this down. So I'm going to add 10 neurons, right? Because we have 10 different classifications. And I'm going to change this activation function to be softmax. Okay, so let's run this and see if I get any errors. All right, so no errors. Let's create a new cell. Now that we're done creating this, this neural network architecture, or the models architecture, now let's compile the model. So just type model.compile, and we're going to give it a loss function. So I'm going to use categorical underscore cross entropy. Okay, so that looks good there. Let's give it an optimizer. So we're going to use the Atom optimizer, and we're going to look at some metrics. So I want to look at the accuracy of the model. So now just run this. Okay, that seemed pretty quick. I'll run it one more time. All right, let's create a new cell. And now in this cell, we're going to train the model. So I'm going to create a variable called hist and set it equal to model.fit. And we're going to train this on the training data set. So x_train and y_train _1 hot, because we did that conversion. And then we're going to give it the batch size. So I'm going to set the batch size equal to 256. And the number of epochs will be equal to 10. And I'm going to split this data set into a validation data set as well. So validation split will equal 0.2, so 20%. All right, so let's run this, and it's going to take some time, so I'll probably pause the video and then come back, and then we'll continue. So let me start running this now. Okay, so now it looks like the model is done. So let's go ahead and create a new cell. And in this cell, I want to evaluate the model using the test data set. Okay, so I'm going to just type model.evaluate, and then I'm going to input x_test, and I'm going to input y_test _1 hot, and I'm going to put in position 1. So let's go ahead and run this and see what the model's accuracy is on this test data. Okay, so on the test data, it looked like the model is about 66.4499998% accurate. So that's not, amazing, but I think for this example it's decent enough. So let's go ahead and create a new cell, and let's visualize the model's accuracy. So just type plt.plot and then type hist.history and then input accuracy. And let's see, plt.plot hist.history, and then we'll put in the val accuracy. Okay, and then I give this plot a title, so type plt.title, and I will call this model accuracy. And then I give the y-axis a label, so I'm just going to type plt.ylabel, and it will be accuracy. And then I'll give the x-axis a label, so type plt.xlabel, and it will be epoch. And then let's give this plot a legend, so type plt.legend. Okay, and the legend will contain the training data set, so I'm going to put train, and the validation data set, so I'm going to put val. Okay, and we're going to put its location in the upper right. All right, then we're going to just show the plot. So type plt.show, and let's run this. Okay, so we can now see the model's accuracy visually. So it looks pretty decent there. It looks okay. We can always do better. Let's go ahead and create a new cell, and let's visualize the model's loss. And what I'm going to do is I'm going to just copy this here using Control-C, and then paste it here using Control-V. And I'm going to change a few things to help speed this up. So I'm going to put in the loss here, and then the validation loss. And then I will call this model loss. And of course, get rid of this comment here. And on on the y-axis, it will be called loss. And train and val looks good. And we'll put this in the, and we'll keep this in the upper left. And actually, let me go up here. I'm going to change this here to the, I'm sorry, we kept this upper right. I'm going to change this to upper left. So if I run this again, there we go. Now move that legend out the way. All right, so now it looks a little bit better. And now I keep this in the upper right. So let's run this. Okay, now, yes, that looks good. So now we can visualize the model's loss as well. We can see it graphically. Okay, and of course, we can improve upon it for sure, but they look okay. All right, so let's go ahead and create a new cell, and let's start testing the model. So let's test the model with an example. So I'm going to upload a file, image file that we can test the model on. So from google.colab, I'm going to import files, and I'm going to create a variable called uploaded, set it equal to files.upload, and let's run this. Oh, one thing, I want this to be a lowercase e. And let's see what's wrong here. This needs to be files with an S. So let's run this again. And let's click on choose files. And I have these images here. So I'm going to choose this cat image here. So let's open it. Okay. And let's create a new cell. And now in this cell, I want to show the image. So I'm going to create a variable called new underscore image and set it equal to plt.imRead, and we're going to read that image file, which is called cat.4015.jpg. So I'm going to put that there. And again, I want to show the image, so I'm going to create a variable called img and set it equal to plt.imShow. And I want to show this new image. Okay, so let's run this. Okay, and there we go. We have the image that I just uploaded. The problem with this image is it's not a 32 by 32 image, so let's go ahead and resize it. So here I want to resize the image. So we want to resize it to be 32 by 32 pixels with depth 3. So from skimage.transform, I'm going to import resize. Okay, and I'm going to create a variable called resized underscore image and set it equal to resize. And then I'm going to input the new image. And I'm going to give it its new size, which will be 32 by 32 by 3. And then I want to show the image. So just create img again, set it equal to plt.imShow. And then I want to show the resized image. Okay, so let's go ahead and run this. All right, and now this is the image above resized to be 32 by 32 with depth 3. So you see it up there, see it right here. It looks good. Let's create a new cell. So now we can use that image and see if the model can predict that this is a image of a cat. All right, so we're going to do quite a bit actually. So let's go ahead and continue here. Let's get the model's predictions. So I'm going to create a variable called predictions and set it equal to model.predict. And I'm going to try to predict what that image is, right? So I need to convert it to an array. So type np.array and then input resized image. Okay, and then let's show the predictions. So just type predictions here. And let's run this. Okay, so these are the predictions of the image or the probabilities. of what the image is, we can see that there are 10 different predictions or probabilities, and the highest one is what the model believes that this image is. Okay, so how do we get that from these values? Well, we're going to do a little work. So let's go ahead and get that highest value. So I'm going to create a new cell, and I want to sort the predictions from least to greatest. So I'm going to create a variable called list index and set it equal to 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, because there are a total of 10 different classifications and 10 different probabilities or predictions. And I'll create a variable called x and set it equal to predictions. And now I'm going to create some loops here to do the sorting for me. So for I in range 10 and for j in range 10, if x at position 0 at list underscore index position I, if that probability or prediction is greater than x at position 0 at list underscore index at position j, then I basically want to swap them. So this is what I'm going to be using to swap. I'm going to create a variable called temp and set it equal to list underscore index at position I, and then I'm going to set list underscore index at position I equal to list underscore index at position j, and then set list underscore index at position j. I'm going to set that equal to the temp variable. Okay, and now that I'm done with that, I'm going to show the sorted labels in order. Okay, so that's going to be from the highest prediction to the lowest prediction. So I'm just going to print list underscore index, and let's run this. Okay, perfect. So now this tells me that in this predictions variable here, the highest probability is at index 3, and the next highest probability or prediction is at index 5. Okay, so that's all that this was for, was to create this nice list for me. So let's go ahead and create a new cell, and let's use this list to actually show us the classification. So I'm going to print the first 5 most likely classes, or yeah, most likely class. So I print the first 5 predictions. All right, so for I in range 5, I want to print the classification. Let's just print the variable here. So I'm going to print the classification at position list underscore index I. Okay, and if I run this, now I can see that this model thinks that this is an image of a cat, followed by a dog, followed by a deer, followed by a horse, followed by a frog. Okay, and it's really that easy. Now, if we want to see the probability or the predicted value, that's just as easy as well. So I'm just going to add a colon here, and I'm going to put predictions at position 0, and then at list index position I, right? And I'm going to multiply this by 100 to get a percentage, and then I'm going to put percentage here, and let's run this. Okay, so now we get the percentages, and I want it to look a little bit better, so I'm just going to round it a little bit. So we're going to round it to 2 decimal places. So let's run this. Okay, so now the model believes that this image is a cat, and it believes it about 59, or with a confidence of about 59.33%. So I think that's basically it. If you have any questions about this model or about this program, leave those questions in the description. If I don't get to them, maybe other people will. And if you like this video, definitely click on that like button. It'll really help out. And if you found this video helpful, then share it, please. And as always, thank you for watching, and I'll see you all in the next video.